Hi guys, and very welcome to this exciting tutorial. In this tutorial I will show you how to randomize rotation along the normals. Let's see first the production setup where you can use it. You see we have only one tree here, and we just randomize the size and a little bit rotation. And also, if you look carefully, there is also some simulation cache offset on the trees. Let's see how you can achieve this. I will show you two ways. One easy way with a digital asset from Houdini, scatter line, and we will build our setup. It will be a little bit more flexible because you can involve this animation offset that you saw in this example. Let's see how it works. Let's see what we have as a source. I have here a palm tree with some wind simulation, and as you see here we have offset. First, what I do, I bring this geometry to the origin, and as an input I have here 2 points. One point is for the leaves and the second one for the tree base. That's why I pack them to get only 1 point to be able to copy to the scatter points. And on the other side I have a grid what I like to scatter the points and instance my packed geometry on. Let's look at the easy way first. Let's create a scatter and align digital asset. And if you hover over the input, it requires a scattered surface. In this case, we have this grid. And what actually this node does is scattered points based on the coverage and also the seed, and also creates pscale attribute and also orient attribute for rotation along normals. If you look in your geometry spreadsheet, you see you have your pscale equal to 1 because your mean and max radius are the same. But if you change the mean radius, you see you got the values randomized between mean and max. And you see our orient attribute is 0, but if you change this slider, you get now randomize orient attribute. This orient attribute will take in consideration the rotation of every instance. Now we have the points with the attributes. Let's use the copy to point SOP. Copy to point SOP to get our source packed geometry into the first input and points into the second. And we look at the result. Let's activate our viewport. And you see first we have tons of trees. Now I can just reduce the coverage here. I will stay with 04. And we have global seed. And now you see I can randomize the size, and also I can, first you see if you just put it this way, every tree has the same rotation and also same size. But now let's randomize the size and also randomize the rotation. And as you see now we have the same tree, but it looked like a different tree because we use the different rotation. Let's look at the hard one. First thing to do, we have to scatter points on our agreed geometry with normal scatter SOP, and then we will use for each point a loop and use this iteration attribute on a details for randomizing rotation, animation, and also pscale. Okay, let's see how it works. For each point, we will get the detail attribute with its iteration. For example, if the first point goes inside this a loop, it will get the iteration equal to 0. Then we will grab this attribute here inside our rotation Y, and we will use the fit function, and we will say, okay, randomize this attribute and fit it between our min and max. You see, I created here 2 sliders. I will show you how to create them too. And I just grab these values and I put them inside this expression here. And what happens here, this 0 comes inside the random function, vex function. It will give me a value between 0 and 1. And then this fit function will take this 0 to 1 randomization and just fit it or remap it to my min and max values. I put it here. The same thing we do here for animation offset. I use here time shift, and the same idea is here. I just take my running frame number $F and I add some offset based on this number. If the second one comes inside this loop, it becomes 1, and the procedure repeats again here, and I will have here and here different values. For randomizing pscale, you can, or scale of the instance, you can use normal transform node and use the same technique for translation here. But I show you one or the other way around this. We will use here this attribute wrangle, and we will just grab this attribute inside this wrangle here. Let's see. I just do a little bit bigger for you. Edit, preferences, scripting, and let's set it to 200. Accept. Okay. What we're doing here, we're just grabbing the detail attribute from the first input here. You see this attribute name is iteration, and with this detail vex function, I just grab attribute from first input. In this case, you already know that the first input is 0 and this one is 1. In case this is the second input with number of 1 or with index of 1, and I put it inside this variable. This will be integer because the iteration is 1, 2, 3, or 0, 1, 2, 3, 4, 5, 6, 7. There is no decimal ending. And what I do here, I create the pscale. The pscale is the attribute that Houdini already recognized. And I just do here, I use here, instead of fit function, I use here the channel ramp because I like to visual change the size of my trees. And you see I give the name to my ramp, and I randomize this iteration attribute. And I put also here the seed. See, I have here a seed slider. You can use only the randomize input iteration here. And it will also work without the seed, but I like to have some randomization too. And at the end of the day, you will have here different pscale values, depends on your point numeration. Okay, now we have our different rotation attributes on every instant geometry here on this side. On inside this loop, we have the pscale attribute. And then what we use here, we use the copy to point and just put the point inside the second input and our packed geometry inside the first one. And at the end, you have this. Now you can just change here your global seed or number of your trees, and here you can change the rotation. It's not doing anything. Sorry, because okay, I have to go to my input 0. Now you see you have the rotation here, your mean and max rotation of the trees, and also you have the animation offset. If you look at your trees now, every tree has a different simulation because they are offsetted. And here you can just play with the size of the trees. If you want to make a couple of them big or small, just use this ramp. Let's see how we can build it from scratch. First thing to do is create for each point SOP and connect the first input to the scatter node. And you see we're missing this block, but this is no problem at all. Just click this button here and rename it to something useful. I will say iteration. And now let's first randomize the pscale. I will create a wrangle node running on the points. The first input goes here and the second input we connect to this iteration block. Let's first grab this iteration attribute on the details. I will create first the variable. I will say iteration, and it will take the detail function. And this detail function needs first the input number. It will be number 1 because the first index is 0, 1. Now we use the attribute name iteration, and now we need the index because it can be float or vector attribute, and as you know, vector has 3 members, and with this index you can pick first, second, or the third, but in our case we have only 1. That's why we pick the index 0. And now let's create the pscale attribute and use the channel ramp. This channel ramp vex function first needs a name. I will say here rand size, and now a value, random value here. It will be result of our vex rand function, and we'll put this iteration variable inside the brackets here. Okay, now if you look here on your result, you will have your points and you will have here the pscale equal to 0. Why? Because we have to first click this button to create this ramp, because now the ramp doesn't exist, and that's why it's giving the pscale value equal to 0. Click on this guy now. You see now we have randomized values from 0 to 1, but we don't need any tree with 0 pscale. You can just play with these values here. Okay, now we randomize our pscale, and let's create copy to point and see the result. I just create a copy to point node, and here these are the target points, and let's take our geometry and put it here. Now you see we have a randomization of the size. Now let's see how to randomize rotation. For this we will use the transform node and connect it after our instance. And now if you look at your geometry and just rotate it in y-axis, every tree will get the same value. Now let's randomize this value based on this iteration. For this we will use the detail attribute, or detail expression. And this detail expression needs first the input geometry. And you see if you just type point and slash, it will go outside and look for the nodes. And you see you have every node existing outside of this node here. If you now type the first letters, you'll be able to grab this iteration node. Just close, comma. Now we need to have the attribute. An attribute name on the detail is iteration. And now we need an index. And as you already know, we have index 0. And if you look now, you have 17 because it goes through every point. We have here 18 points. Numeration begins with 0. It now goes through every point and just grab the last value here. Okay, great. Let's just what we have now. One tree will have 0 rotation, another 1, 2, 3, and so far. But I don't like have this rotation here because they are very small and will not see them. What you can do here, you can remap this value from 0 to 17 to something you like to have. Let's see how to do this. First, let's randomize this value with a random function. Click here, and I'll do this in one external editor. Just press Alt-E and you'll get this external editor. I use here random expression, and now this value is randomized between 0 and 1. And now let's use another expression, fit1 expression, and let's randomize this incoming 0 to 1 values to something we can use for rotation. For example, minus 360 and 360. Close the brackets, apply and accept. We have some issue here. This random function have this one. You see, I have one more here. Still giving me an error. Oh, sorry. I just like to put it here. It was right. This detailed function take this, then the run function take this one, and actually now it have to work. Oh, sorry, I forgot to put a fit here. Okay, great. Now we have the randomize rotation along the normals. But I hard-coded this. I like to have some control over this values. What I like to do here, I will create sliders, and I just involve these sliders inside my code here. How to do this? It's very simple. You just click here, create these two sliders using the float here. Just bring it here and go to parameter and give a name. It will be min rotation. For the level, I use here min rotation, and I give a range from minus 360 to 0, and my default value I like to have minus 360. Apply, just copy this guy and paste it. And now let's change the parameter name first. It will be a max or max, and here also max. Range will be 0 to 360, and don't forget to change this guy. It will be 360. Apply, accept. Now you have these values here, and now let's connect this slider to this expression. It's actually very simple. Just copy this parameter with right mouse button, just go inside expression, highlight your value, right mouse button, paste relative references. The same thing here, just copy parameter, click inside, highlight your value, and paste relative references. And now you see, if you use your sliders, you can randomize your rotation. Okay, great. Let's see how to randomize offset of the simulation of the alembic file. I will use here the time offset or time shade. Just connect it in between. Click here to get this expression. And now what I like to do, I just copy and paste this whole expression because I'm lazy. You can do it this way, Alt-E. Just copy this whole expression. Just copy it. And do a plus, or for testing I do first minus and paste this whole expression. And you can also create your own sliders here, but in this case I will hard code them. I just say, okay, 20 will be minimum, and maximum I like to have 50. And now you see your result. You see, if you grab your timeline, you see now first one, second, third, and you see you have now your offset. And let's change it now to plus. Minus was only for testing. And now you have your simulation offset. Okay guys, that's it for this tutorial. Thank you very much for watching. If you like this one, give me a like and subscribe my channel, and I'll see you in the next one. Bye.